Assalamualaikum and hi everyone. In this video, I would like to introduce about the DC biasing. BJT we usually use as amplifier. In amplifier, we have two component, which is we have the DC sources and also we have the AC sources. Okay, for the DC sources, we use as a biasing. Why we use the biasing in amplifier? Because of usually the signal starting from the zero, okay, without the biasings. So it's starting from zero, meaning that we have the positive cycle and then we have the negative cycle. If you have a kind of such kind of this signal, it's quite difficult to amplify. So we have to put the bias to shift up or shift down the signal to be in positive value or negative value. For example, for the positive value, let's say this is the positive biasings. We have the positive 5 here, and then this is your your origins. So your signal will start from the 5. Mean that it should be here like this. So in other words, BJT the value of the operate in active region to be used as amplifier. For the cutoff and saturation regions, we use as a switch. For the active region, what you need to remember is BE junction is always forward bias and the value is 0.7. It's same as a silicon. So for the notations, for NPN transistor, we use VBE. Okay, so this is the NPN transistor, so 0.7. While for the PNP transistor, we use VEB because of the opposite current directions. So the value is the same, 0.7. So BC junction is always in reverse bias. This is very important thing we need to discuss before we can proceed, which is the notations. Because of in some textbook we use the different notations. Okay, for example, for the RC, it's not VC, we should use the VRC. And then for the RB, we're going to use VRB. And for the RE, we're going to use VRE instead of VE. Okay, this should be not equal to VE. This is not equal to VC. This is not equal to VB. Okay, where is the VB? Actually, in VB, in transistor, we always use for the base voltage, which is here. This is the positive, and then this is the ground, so it should be minus. So VB is between here and here, between the base and ground terminal. This is your VB. Okay, and then for the VC, it's from here. Okay, it's here to here. So this is the positive because of the current flow. This is the minus. So this is your VC. Where? So I think you can make a guess where is the VE. Okay, VE should be here. So meaning that is between E terminal and also the ground terminal. This is the minus, this is the positive, and the value is VE. Okay, in this case, VE is equal to VRE because between E terminal and ground terminal, we only have the RE. Okay, but for the VC, it's not equal to VRC because between C terminal and ground terminal, we only have the voltage drop at the transistor and also voltage drop at RE. Okay, but for the VRC, it's here. Okay, it's the two different things. Okay, for the equivalent circuits, this is the installation for the equivalent circuits. For the DC voltage, what you need to do is, because of the parallel, you can split this one to be 2. So meaning that you have one VCC here, the value of VCC, and then connect to ground. This VCC, and then same goes to here. You can draw here as a VCC, and then connect to ground. So this the value is VCC. Okay, let me draw. In DC and DC, you have to remember the capacitor will be always open. This one always open, so that for AC input signal we can ignore, and also AC output signal we can ignore because of the open circuit here. So let me draw the equivalent circuits. So from the left, we have the VCC. And then from the positive terminal, it's going to be to connect to the RB. And then from the RB, it's connect to the base terminal of transistor. And then from the E terminal, it will connect to the ground. Okay, it's connected to the ground. Okay, forgot to mention this one is also connected to the ground. And then here from the C terminal is connect to RC. So from the RC it will connect to the VCC again. Okay, we have the VCC, and then from C is connect to the ground. So if you look here, we have the three ground. Actually, it's a same ground. So meaning that we can connect all this point. So if you can see here, we have the input. We have the input section here, and also we have the output section here. This is your RB. Okay, this is your RC, and then this is your VCC, and also this is your VCC. Okay, I think this is a better way to represent your equivalent circuits. We have two sides, and then we can analyze this in different KVL. We have a lot of bias configurations, but I will cover only 5, which is fixed bias configurations, emitter bias configuration, voltage divider bias configuration, DC bias with voltage feedback configuration, and also miscellaneous bias configuration. This is the example of the fixed bias, and this is the emitter bias configuration. This is voltage bias configuration. Okay, it's really recommended that you have to watch this one first, because I think this is the most critical bias, because of what is the difference between fixed bias and emitter bias. The difference is here. Okay, in fixed bias do not have the RE, so for the emitter bias we have the RE. And then we also can compare voltage divider bias configuration with the emitter bias configuration. The difference is, yeah, the notation is different. Instead of RB, they use R1, and they have another resistor here. We have the R2. Okay, that is different. And I'm going to suggest you to study or to watch my video regarding this topic first. Okay, and then you can go for the fixed bias, and then next you can go for the voltage divider bias. Okay, that's all. Thank you for watching.